All right, I think it's recording. This is a supplement of the two independent sample t-test. As I noticed that there's an error. There are some, errors or what you might say because of it's not actually an error. But I was not. I thought I was showing the table, but I was not showing the table. So when you are hypothesis testing, you inevitably consult your table of critical values, right? So let me, for example, if you have always, all right, I have 20 observations in all. For you might imagine there are 10 in sample 1 and 10 in sample 2, 10 observations sample 1, 10 observations on sample 2. So in this case, you have 20 observations and your degrees of freedom should be 18, right? So you set your significance level maybe at 0.05, and your critical T should be consulted in the table. Your critical T should be what? So let's consult our table. If you have these events, your table, it's your. All right, let me just committed the mistake of. Let me just share my screen. Sorry for that. I have a cold, so you're critical for that. This is your T table, critical T table. For the cells are the critical values of the T, and the columns here. The column level gives you the probability of this T to the right of this T. The cumulative probability to the right of these T's that are in the cells, right? So let's say if you have 20 observations, you have 18 degrees of freedom here, and you set your significance level of 0.05. Your critical T is 1.734 there. So 1.734 is your critical T. Let me have my, instead of drawing like this. Okay. So if you have your, 20 observations, 18 degrees of freedom, then your significance level is 0.05. So your critical T is 1.734. You set that yourself, no? That's your, what does it mean? Well, the probability of any T higher than 1.734 is less than 0.05, because it always decreases to the right, since the sum is 1. So if this shaded area is 0.05, then given our degrees of freedom, that should be 1.734. So anything to the right of that should give a lesser probability, lesser than 0.05, because it's always decreasing, right? From 0.05, because the total area of this should be 1. So you know that that's smaller and smaller areas added once to the right of 1.7304. So if you have a T, for example, if you have a computed T in your experiment, that's for example 2, 2.0. So you know that 2.0 is to the right of 1.73, maybe here. And you know, of course, that the probability of anything higher than 2.0 is less than 0.05, because 0.05 is already the here, way up to the left of that of 2. Right. So you know that this is, if this is 2, then you know that this is less than, this area is less than 0.05. All right. That's what it means. My hypothesis testing. If you know a t, if you have a t that is greater than 1.734, and you do, given these facts about your experiment, you know that it's rare to get a higher t. It's very rare, at least low probability. So you, in this case, you actually you have enough proof of your t being high enough, which means your mean differences are high enough, are high and high enough to be different from 0, right? Because, you know, your null hypothesis is that the mean difference is 0, or which is about the same thing, x1 bar. This is x1 bar. Oh, sorry for that. Is equal to x2 bar. That's your null hypothesis, or the mean difference is 0. That's your null hypothesis. And if you have a t value that's high enough, where anything higher than that gives a low probability of occurring, then you accept your results to be very significant, meaning your unequal means are significant, right? Significant t-test result, right? So that's how it's done. Yeah. Well, it depends on your significance level, right? If you are very stringent, want to be very stringent or very strict, or very, you know, not risk-taking at all, you're very worried about risks for experiments, risks to be wrong, then you can have a very low significance level, like 0.01. It's also valid. So you set the cutoff t to be 2.552. That's for the degrees of freedom rating. So anything you should get a t. If you get a t higher than this, then your results are significant. But if it's lower than this, your results are not significant. Right? Okay. Thank you. That's about the t-test.